So in science, we often use numbers that are massive, such as when we're talking about light years or astronomical units in space, or we use numbers that are very, very, very small, such as the gravitational constant. When we use when we work with extremes in numbers, very, very large or very, very small, it helps to use what's called scientific notation. So the general format in which we write scientific notation looks like this. We have a number, so this is a blank, I'll put a number here. And this number has to be greater than 1 and less than 10. We write scientific notation, this is the general format. We have a number times 10 to an exponent. Okay, this number is between 1 and 10. Okay, so 1 to 10. The exponent, if it's a positive exponent, if positive, the whole number is greater than 0. Greater than 0. If the exponent is negative, the whole number is less than 0. If the number is positive, if the exponent is positive, that means the whole number is greater than 0. So here is the general format. We have a number between 1 to 10. We multiply times 10 to an exponent. If the exponent is positive, that means the whole number is greater than 1. If the exponent is negative, the whole number is less than 1. So, for example, if we're looking at the gravitational constant, which is really Newton's law of gravity, includes this constant that shows the proportion of the force of gravity between two objects. So the gravitational constant is a very, very, very small number. It's measured in newtons. Remember, newtons are a measurement of force. And 1 newton is equal to the force needed to move 1 kilogram 1 meter. So to move something that weighs 1 kilogram, which is like 2.2 pounds, to move it 1 meter, which is a little greater than 3 feet. The force needed to do that is called 1 newton. It's not fig newtons, newtons. Okay. So the gravitational constant is 6.674 times 10 to the negative 11. That's the scientific notation. If we were to write out the gravitational constant, it would look like this. This is the gravitational constant. Look at this. 0.000000000006674 newtons. That's a lot of zeros. It's a very, very small number. This is hard to write out. This takes a lot of time to write all those zeros. So instead of writing all those zeros, we're going to write the gravitational constant in scientific notation. So how do we do that? First of all, we have to get a number between 1 to 10. So if we look at the numbers in this gravitational constant, I have to move this decimal either to the left or to the right until I get to a number between 1 and 10. So we move the decimal all the way over here, but right here, we would have a number. So if I move, So if I move the decimal all the way over here, we would have a number now that's between 1 and 10. In fact, it's 6.674. So let's write that right here. And that number is between 1 and 10. There is no other number you can get by moving the decimal that would be between 1 and 10. Right here. Now we're going to multiply times 10. And I have to put an exponent here. Now I had to move this decimal 11 places to the right to actually get to a number between 1 and 10. So I had to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I had to move 11 places to the right. So 11. The number is less than 1. This number is way less than 1. Remember, 1 would be 1.0, right? It's 1. So the exponent will be positive if the number is greater than 0. The exponent will be negative if the number is less than 0. So we can see this number here is way less than 0. So it's a negative. And this is scientific notation of the gravitational constant. Scientific notation, you can have these numbers that are very, very massive or very, very small and multiply or divide them very easily. 680 trillion kilometers. Now, it's a lot of zeros. Anytime, if we have a decimal in here, it would obviously be right here, the decimal number, or the decimal point would be right there. So this is the same thing, right? Now I'm going to have to write this in scientific notation. So we're going to have to move the decimal till we get to a number between 1 and 10. So we're going to have to go this way till we get to 6.8. So 6.8 is a number between 1 and 10. And I'm going to have to multiply times 10 to an exponent. And what direction did I have to move that decimal to get to 6.8? I had to move it to the left. How many times did I have to go? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 spaces. Okay? This number is way bigger than 0. So the exponent is going to be positive. So this is your answer. So this is scientific notation. It's a lot easier to write this versus this.